Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is to just lay back and do relatively non-challenging stuff. In case you missed it yesterday, in case you really missed a lot of what I'm doing, I'm developing this library to help you develop JS effects, which are these real-time audio processing thingies in Reaper. And I want you to be able to have better looking JS effects and provide you with some digital signal processing algorithms that most people are going to need. And in case you missed it yesterday, I was finally able to complete this humble but somewhat working implementation of the discrete Fourier transform. And this is not the more widely known fast Fourier transform, it's the discrete Fourier transform, so it is the more, well, it's slower and not really practical, but it helped us really understand what the discrete Fourier transform is, or what the Fourier transform is in general, because we implemented everything with our bare hands. It was awesome. And this is what it looks like. It's just a spectrum analyzer, but it's being plotted here in linear form, so all the information is kind of concentrated on this area, but it is reacting to my voice in real time. Amazing stuff. But it was a lot of work and conceptual and hard work. And this is Friday, so I thought, why not do something relatively simple? Something that we know how to do and that we will succeed in. Low-hanging fruit that is necessary for the library to move forward. This is actually the second version of the library. The first version fell on its face for performance reasons, and we wanted to change some of the architecture so that everything would be all the colors, all the objects would be values. So we are talking about real objects as opposed to pseudo objects and that sort of thing. So what we are going to do today is to port over some of the features from the old version that have not been converted into the new version yet. Specifically things like colors and spaces, the kind of thing that would help you draw this graph in a way that looks better, right? This graph is great because we did it with our bare hands, but it doesn't look awesome. Let's make it look better. I have here the current version of the library as well as the previous version of the library. This is the previous version. And on the previous version, we had a bunch of things that we are going to convert. And I think I already removed from this file everything that we don't want to convert. Did I remove everything from this file? Let me see. So again, low-hanging fruits, keeping it simple. So let's just go over the design system again. So we'll see things in this file that we want to convert and things that we don't want to convert or have already converted. So in terms of sizes and font style, I think that we'll change definitely the naming convention. We are not starting with L anymore. We're starting with underscore because it sorts better on the debugger. And we don't want everything to be functions. We want things to be values. So we'll have to do that bit of work as well. So all of this stands otherwise. The fact that we have these numbers and whatnot, the colors are going to be migrated as well. And then all the font stuff still makes sense. This drawing function does make sense. We'll need to change the naming convention and whatnot, but otherwise it stands. Then the unit testing thing, that is no longer valid. And I think that this is already through here. So we don't need that. How about we start... Bo is here. Hey Bo, it's great to have you on the stream. and Bo is watching us from bed. Okay, it's great to be in bed with Bo writing code. Very laid back and intimate. This is gonna be a fun stream. Right, so yeah, Bo, what we have on the menu today, simple stuff. We're just converting the numbers from the old library, the design system from the old library into the new version with the new naming scheme, new architecture where everything is a value, that sort of thing. And I would like to start with the drawing functions because they're relatively straightforward, but they depend on things like colors. So I think I need to leave them for later. In fact, well, there is this style setters, but they need, well, the size is a value, the style is a value, and then the color here is a value too. So we could start with that. Oh, I'm sorry to hear that. Bo said that he's having a bad day. Well, I hope this brings you joy. The joy of programming being spread. Yeah, this is going to depend on the definition of colors as well, so we need to think about the colors first. Okay, so let's start with maybe the easy stuff. Sizes. Sizes are going to be easy. In fact, we may be able to do a big transformation on this file for the naming convention to just replace 2 underscores with a dot globally. And that brings us a lot closer to the naming convention that we are following. And then everything that starts with L underscore, we can replace with underscore dot. Oh, Bo, do you have COVID again, or is it like a side effect of you having had COVID in the past? Because I know that it has some lingering effects for some people, I guess, including you, but do you have it again? That's too bad. Okay, so this gets us a bit closer to our destination, but we want all these numbers to be values. And there is the issue of the X retina thing, which is only available in the GFX block. So even here in this initialization thing, we are not able to just define our spaces in there because the GFX retina is not available. So I think that what we need is to have another one of these functions that you as the user of the library, so a developer using the library, will have to call this function in the GFX block. Here I have a demonstration kind of effect that I am using to try everything and test everything. So I'm establishing this new thing. You have to call the GFX function from here. But I don't want to reinitialize the whole thing the whole time, right? Because this is going to be called 30 times a second, once per frame. And I don't want to reinitialize and remultiply everything. So I am just going to check if I have been called before. I'm gonna have a variable called first time equals 0 or false. No, I don't like this. I don't like this name. There is another way of doing this, and I may just do it. You know what? Maybe executed. Yeah, okay. So if the GFX has not been executed, Then I'm going to execute it. And the first thing I have to do to execute it is to say that it has been executed. So I can just say it has been executed. Maybe I'll have all of these in a single line to be like the setup for the situation. So if it has not been executed, then execute it. This guarantees that I will only run this once. Let's see if this actually works out. So I have here a debug variable that I'm adding. So this debug represents the number of times that I ran this. And I actually will have two of these. One is debug outside, and the other is debug inside. And then I can load the effect here and go to the debugger. And I can see that the debug outside is being called once per frame, but the debug inside is only called once. So the strategy here that we are trying to use actually works great. It's not that you recovered from COVID, you are still having effects from it. That's terrible. I'm so sorry to hear that. I was gonna ask, is the multi-channel loop thing included in the library? And Fatis and Stuff says, hello everyone. Hello Fatis and Stuff, great to have you here. Okay. Your question is actually a good one, and I wanted to have something like this. So for people who do not know what this is about, I can show you an example of something that is mildly confusing for people who are new to JS effects, and it's this loop. The intent is that I want to run a block of code, namely this block of code, for once per channel. And to do that, I set up a loop where I start the channel counter at -1, then I loop for the number of channels, and then I increment that counter. So this block is going to run for the number of channels, and the GFX channel is going to be the index of that channel. For instance, channel 0 is going to be the left-hand side, and so forth. And then the question is, can we include this in the library? And as far as I can tell, the answer is no. Because to do that properly, to do that in a way that I would like to present it to the user, I would like to be able to receive this block of code as an argument, and then I could have a loop in my auxiliary function in the library, and I would keep calling this block of code. The problem is that, as far as I can tell, functions in JS effects cannot receive blocks of code as arguments. Now, it may seem like that's the case because the loop thing here kind of looks like a function call, and it is receiving a block of code as an argument. The first argument is the number of channels, which is the number of times you want to run the loop for, and the second argument is the block of code you want to run. But loop is not really a function. It is a looping construct that is embedded in the language, and the JS effects engine, the processor that processes this thing, that compiles this, the compiler, in other words, is aware of the loop thing and is a syntactical construct that is privileged. We as developers cannot create such a function. We couldn't recreate the loop function in the user space. So that's not a way of doing, there is no way of me embedding this loop construct somewhere else, tucking it away, and then receiving this block of code. And this is how you would do it in languages that have the so-called first-class functions or functions as values. Not first class, sorry, higher order functions, that's what I meant. And then this block of code could be encapsulated in a function, and then you would pass that function as argument, which is something that you can do in Lua, for instance. In Lua, if we were writing this in Lua, you could have a function that would know this logic of traversing the channels, and it could receive as argument a function to be executed once per channel. Fortunately, in JS effects, that's not the case. So I guess the best they could do is have library functions for the -1 and +=1, but then it's like, and then you could have like a box, which is a data structure that we already have. It's just a single place in memory. So we could have kind of a box to keep the number of channels around. I don't see a point. I don't think it's advantageous to do that. So I considered that for a while. I wanted to tuck away this complexity of looping. It's something that is jarring especially for newcomers. But I couldn't find a good abstraction for this. I couldn't find a way. Yeah, get well soon, Bo. And Fotis, I know that you were not here for some of the latest streams, and I am so proud of this that I want to show this to you. So check this out. This is a very simple frequency spectrum analyzer, but what's cool about this is that we developed it from scratch by hand, and we went over the whole theory of Fourier transforms. It was awesome. So you may want to catch up with that if you're interested in like the low-level nitty-gritty of how to do mathematics, I guess. It's fun stuff. I liked it a lot. All right, so this whole idea of having a loop or having a block of code that is going to execute only once works. Next, we can define these values. So I'm going to not have this as functions. I'm going to have this as values. And the cool thing about being in the GFX block is that I can have access to the GFX X to retina, so I can calculate this only once. So that's another advantage of having this as a value. The first is that this is a value. Now I can pass it around as arguments to functions, which may be good. The second cool thing about this is that now I will only compute this multiplication once, and I will cache the result. Not that this is a huge advantage, not that this is like a huge performance gain, but it's not negligible. So there you go. These are variables that we define, and they become global variables, and they are the numbers that are our line heights and font sizes. Great. Yeah, you want to watch that. I'm so proud of my explanation. Not that it's perfect, but I think it is relatively intuitive, and all the formulas have been implemented very straightforwardly, and I explained the reasoning behind most of the formulas. So if you look at the implementation of the DFT, really the whole thing is in these lines. And I'm not going to say that these lines are trivial, but really these lines are only fetching stuff out of data structures. So in essence, this is the DFT. Such a simple concept. It's beautiful. And I'm not going to lie, there is another complexity here, which is... so there is also this part where I convert the output of the DFT into magnitudes that I can plot on the screen. And then there is also the function to do the plotting. But if you put all this together, it's like 30 lines of code. Very cool stuff. Very cool stuff. I was thinking for the init block, not the GFX, if that would make a difference. Yeah, so the issue here really is this variable. This variable is only available in the GFX block. So I have to run something once. And of course, if you have to run something once, it makes sense to run it on the init block. But the GFX retina variable is unavailable there. So we need to run this on the GFX block where the variable will be available. But we only want to run this once, so that's why I came up with this trick, just using a global variable as a flag to determine whether I ran this block or not, and if I already ran the block, I don't run it again. So this is sort of an init within the GFX block. And Fotis asks, Are you familiar with synesthesia? So that is like when two senses, like vision and hearing, get mixed up in the brain. So you hear a tone and you say that that tone is blue. I'm familiar with the concept, yes. And I have some of that, but not really with smells. I do consider some smells blue, for instance. But it's rare. It's not every smell that has a color for me. And definitely not sounds. I don't have any sort of synesthesia with colors and sounds. Right, so moving on to font styles. This, in theory, could live in the init block because it does not depend on GFX X to Retina, but in practice, I think that it makes more sense for me to define the whole design system in one place. So I'm going to keep everything together. So this one is easy. To convert this, all I gotta do is this. Exactly, I have it, and I have a lecture on that on my channel, including my mockup for an app that I'd love to build someday. Okay, I will check it out later, of course, not right now. I will actually make a note of this so I remember. Check Fotis video on synesthesia. All right. Then we have these flags for text alignment. That is also trivial. In fact, I can already tell just by looking that most of these things are going to be very similar. I'm considering doing everything in one pass. Of course, colors are different, but everything up to this point is the same. So I can do it like this. And then at the end, I do that. And then there is a wrinkle where I have to get this part and convert it into an equal sign. So I'm going to reselect everything. And if I was in Vim or Emacs, I could have done this more easily. But in Visual Studio Code, I don't know how to do this kind of movement in one pass. But never mind, that's already over. Oh, I forgot a few. There you go. And now for some good indentation in there. And there you go. We are making progress fast. Have you been updating the Repack XML? My Repack hasn't been updated since August. Let's see. How do I see the history of just this file? Well, I know how to do it on the command line, so I'm going to do it on the command line. Git blame index HTML or XML really. And it seems like the latest update was in October. So oh no, this is October 2020. So this is July, and yeah, I think you are right. Yeah, I don't know how to see the last commit that touched this, but oh, there is another easy way of doing that. Just go to GitHub, Repack, Reaper. And yeah, 3 months ago, sounds about right. August. So yeah, Fadis, you are right. I have not been updating the Repack for new effects. I haven't developed any. I'm working on this library. And the library, I am not pushing to Repack because it's far from being ready. So that's the story. Now the colors, I could try to apply a trick similar to what we just did with everything else. But I think that colors are special. I would prefer to rather update the script here that generates all these colors. First, because I may want to reuse this in the future if the colors change, but also as I'm considering using a different representation for colors. So I actually have to think about this. Before I think about it, I will commit. Yeah, everything looks right. So currently I'm representing colors with a function, and we know that that's not going to fly. We are going to have these colors as values. Then we could represent these values as three different numbers. Three different numbers being red, green, and blue, composing a color, and that's great. But we could have this as a single number. And then we could pack that single number using this formula and unpack using the reverse of this formula. And there are advantages and disadvantages to this. The advantage is that a color is a single number. That's super cool. It's much more ergonomic to have a color as a single number instead of having three different numbers. For that, I would need some sort of position in memory, I think. Or we could use pseudo objects here. But we are not using pseudo objects anywhere else, so I don't think that's a good idea. So advantages of packing everything in a single number. It's a single number, super ergonomic. Disadvantages. Every time when we want to set the red, green, and blue, we would have to unpack the number because GFX clear works with this packed representation, but RGB does not work with that. So I guess we have three options. Option 1, pseudo objects, and then it would go something like this. And then I could have a function that would receive a color as a value. So say that the color F receives a color, and then I could have a pointer for a color. And then in there, I could do something like this. And to actually call the function and pass this color as an argument, I could do it like this. This is option number 1. It looks nice, it's super fast, it's relatively straightforward, but it does use this pseudo object notation here that is actually now not documented. It's something that I found by looking at other people's code. And we talked about this in a previous episode, but yeah, it is not the best, I don't think. It's kind of obscure. Option number 2 is real objects. And then in that case, a color would be a position in memory. So I would need a struct to be color. So I would need to have something like color struct equals struct define. And then I would need 3 fields. That would be red and green and blue. And then to define a color, I would do something like this. And now let's enumerate the advantages and disadvantages. So this is it's fast. It's relatively straight. Well, it's kind of obscure. And yeah, I think that's it. It's fast, but it's kind of obscure. And this is somewhat slow because of memory access. Every time you want to fetch one of these colors, you have to access memory 3 times. But it's consistent with the rest of the library. And then there is the third option, which is a packed representation, where a color like this is represented as 0.4. I guess I'll do it like this. And this is relatively slow because of division. Why division? Because to be actually able to use this to do something like GFX red, I will need to unpack this number. So I would need to get the color. So let's say that I have a function f that receives a color as an argument and that wants to set this color, that wants to assign this color. So I would need to get a color and divide by 255 or something like that. I don't even know what I would need to do. Yeah, I would have to like divide a bunch of I would have to divide, but I would also need to get rid of all this junk in there. So I would need to unpack the representation, doing a bunch of arithmetic. So it's relatively slow because of arithmetic. But there is a precedent, which is GFX clear. And yeah, that's the trade-off, you all. Do you have a preference? Do you want to vote? Let me know which version you prefer. Guess this is the trade-off. And I'm not even sure if I know how to write this function. I mean, yeah, we know how to write this function, but it would take a little bit. I guess I would mask these bits away. That's how I would do it. I would do a bit mask, and then I would divide by 255. And the reason why the rest of the library doesn't rely on pseudo objects, but this could, is that in the rest of the library, I want to be able to assign colors, or not assign colors, but I want to be able to do things like a loop over the channels and create a delay line per channel. But this is not the case here. I'm not going to loop over and create colors. Well, I'm not going to, but I may. Yeah, and this is not really a value, is it? Because I can pass it around in a function, but I cannot get the address of it. So if I wanted to have some sort of list of colors, something like this, I cannot do it with this representation. This representation is bad for the same reasons that we decided not to go with it with the rest of the library. Now, of course, you can have an array of numbers, so this representation is fine, and this representation is also okay. This is kind of obscure and hacky, and this is consistent with the rest of the library. And a memory access in the GFX block is kind of not a big deal. So I think that the votes are in. We are doing it this way. So let's define this data structure. To do the memory allocation, I'm only going to do this once, so it's relatively safe for me to do it on the GFX block, but for a good measure, I'm going to do this on the init block. I will have a data structure for colors, and I think that colors are going to be the only thing that need this sort of data structure. So I'll come here to the initialization block, and I will have something like GFX init. Not to be confused with this function, that's a different thing. But now I need to move this up so that this is the thing that I'm going to try to do is going to work. I'm going to have this in a block called design system. I'm going to paste it there. And we have the init thing at the top. For instance, here on the filters, the first function we define is the init function. So, all right, let's do this. We are going to define this function. In there, we are going to define some data structure. Well, I think I nailed this the first time. Pretty confident. Let's see if I got the names right. That's the right name, and then this. And then red, green, and blue. Yeah, I think I wrote everything correctly the first time. So I'm just going to move on. And then to define the colors, I will do something that looks like this. So now we have to revisit this script where we are writing some JavaScript program that generates JS effects that generates this. So how about I just paste this here and we copy the whole thing into a JavaScript buffer. And then this whole thing is commented out. There you go, that's better. So this is just an auxiliary function that I want to keep around, but not necessarily is part of the color situation. So I'll paste it there. Then for the color situation, we are parsing it. Then we are getting the name, the red, green, and blue. So we are mostly interested in this part. How about I do this with a let, and then I do all this renaming and calculations that I'm doing. I'm going to do this before I console log anything. And I don't want to replace the dashes with underscores. I want to replace double dashes with a dot. That's the new naming convention. And then red, green, and blue. Red, green, and blue. We will say that they are equal to parse int. I'm just copying this logic here from below. Parse int paste 16 divided by 255. What is FF? Let's check this out here in the console real quick, because I'm always doubtful if I got 255 or if I should have 256 instead. I am never sure if I got this right. So let's test this. Parse int of FF base 16, that's 255. And divided by 255 is going to be 1. So my values are going to range between 0 and 1. And of course, 0 in this case is literally 0, 0. So yeah, I got it right. It's 255. So now that I did this, I can remove this whole logic, which was kind of messy. And I will have something like underscore dot name equals. Oh, actually, I will need. Let me see. No, it's just equal to that. Then new line. Then essentially it's similar to this. Let's copy this over. Then in this line, I want to change this into name. And these are right, and then I just do that. Well, I do this. Yep. Let me remove this dot, go to the console and run this real quick, and let's see if this is right. It seems to be. Yep, I think this is right. So now all I gotta do is go to my design system. And let me actually get the latest. Is the latest the same as I had before? Yes, it seems to be. This hash is the same. Yep, it really seems like I have not changed anything about the design system since we started this whole endeavor, which is good news actually. It means that the design system is stable because I keep using it on my day job and all my side projects and everything. If I try to select this, it's gonna work. Okay, so let me find the colors. Transparent and current color don't make sense, but everything else makes sense. So let me just grab everything just like that. And then I can paste it here. And then we can run this. And here are all our colors. Not sure I like this spacing situation going on here, so let's change the script to remove that. There you go. These are all the colors we are ever going to need. Oh boy, there are lots of colors in here. Lots of colors. Oh no, I had two equal signs. Check this out. God damn it. We'll have to do it again. You know what? Here's what I'm gonna do real quick. I'll call this hello.js, and I'm going to run it like this node, hello. I'll be in the right directory and I will run node hello.js, and I'm going to pipe into pb copy, which is this macOS app that copies anything into the clipboard. So now I can just come here and paste. And when I keep saying that if this approach of real objects doesn't fly for whatever reason, probably performance, I keep saying that there is an alternative, which is to meta program, which is to have JavaScript programs that generate JS effects. And this is what I mean by that. And I'm trying to limit this as much as possible. I'm trying to not really rely on this too much. As the developer of the library, I'm okay with doing that. But as a developer of JS effects in general. I don't want to push this complexity into the user. And by the user, I mean the developers using the library. But just so you know that this is what I mean. So programs that generate programs, super cool stuff, but fairly advanced. And then let me paste the program that we used. And naturally, I also need to comment everything in here so it doesn't try to execute this as if it was JS effects. And it isn't. It is not JS effects. Some good old window management, and let's see what we have. So I got rid of, let me go find the script again. Let me put the ... in there, or not really. It's kind of clear what's going on. Saving this for the future, though I really hope that we settled on this and we won't have to touch it again. But you know how these things are. Then I can delete the hello file. I really like how Visual Studio Code tries to scream at you to really make sure that you're not going to make a mistake. But in this case, I do want to delete the file. Then let's commit what we have, because we changed a lot of things. In terms of numbers of lines, this is probably the biggest commit we are going to make in the project. All right. And let's see the styles setters. Let's move them over. And this doesn't have to be inside of any function. So I can just try to find the end of this function. And oh, I can actually have some extra lines in there. And then paste this there. And then let's look at this again. So the size and the style are just going to be variables. So that's fine. And then the background color, given a color. Okay, so this background color function is going to work with the packed representation. GFX clear works with the packed representation, but we are now working with packed representations. So we'll have to do something that looks like this, where we say color at red. Now this definitely needs some new lines. Color red, color green, and color blue. I'm doing this the long-handed way, like defining local variables for all these things, because I think that I will need this in the near future, so I can just copy and paste this snippet, and it also reads better. So that's what's going on. And then we have some drawing functions. So let's port them over, and we'll be done with the porting of the library, but we still have to port the demonstration using the old library, because there is still some good stuff in there that we want to port over. But we already have some drawing functions. The line graph thing. Maybe we should bring that here. Line graph. And then we probably want to add some options for this, like color, now that we have colors. But let's see this first. So font, a string, and then font size. Maybe we should have font dot size. Do we want that? Let's see. No, I think it's more like the CSS font size property, the CSS line height property. Yeah, okay, so we'll have just font size, but in this case, but what is this function? Oh, this function was one of the functions that we had to actually set the font size and style. That one. Okay. I'm tempted to do it like this. Font size. No, this is like the CSS property, so I'm going to keep the underscore. Font style. It's like a single word in this context. Always thinking about naming conventions. Text align, horizontal and vertical. I wonder what the text align stuff looks like, because I forget. Okay, that's great. Text align horizontal and vertical, and text overflow, and then color, and X and Y and width and height. Okay, so the color changed. The color situation before was kind of a hack where you pass the color as an argument, but then it would set as a side effect the color, and we don't have that anymore. So we need a style setter for color. I'll define a function color, given a color, and now it's a place where I already need these local variables. Well, not quite. I can do it like this. Just this once, because I only need it once and it's kind of setting anyway, so there you go. And then I set the font size, I set the color to be the given color, and then I set X and Y, and then I draw the string using the good old GFX draw string situation. And I think that is all. All right, that is all. Let's drop the effect in Reaper and try to weed out any syntax errors, but I'm not really gonna migrate the demonstration to exercise everything. But yeah, there are no syntax errors. We nailed this first try, which is amazing. And then this file is empty, so I better remove it. And that is it. What's next is to have this demonstration that is a legacy. So in this, we have pages that we are not ported over. So you can see that there are some pages here, but there are all these color pages that I have not migrated. And they are going to use the new design system. So I have to port over this. And that may or may not be what we are going to do next. So the plan for now is, let me just make sure that at least this much is still working. Yeah, seems to be working. And then these filters, I will not really test them. And this is like our beautiful spectrum analyzer. So the plan is the following. I'm going to wrap this up now, and I wish you all have a great weekend. On Monday, we have a very special stream over at Aria's channel, IDDQD Sound. Justin of ReQ fame is going to be joining us, and we'll talk about JS effects, of course. And this is the ReQ that I'm talking about, not ReQ. Also developed by a Justin, but a different Justin. We're talking about this Justin. He's going to be joining us on Monday over at IDQD, and then on Tuesday, I think I'll be back to writing the code that we are writing, and I will be probably porting over this because it is such a fun little thing to do and it's relatively straightforward. So yeah, Fotis is saying that req is better than req, and I agree. I do love all reqs, but I prefer this. All right, I think that's it for now, and I wish you all have a great weekend, and I see you on Monday over at IDGQD for some req, and then back here on Tuesday for more of my library. Have a good one. Bye.